Hello, welcome to Paramount Homes Energy Modeling and Optimization. This is where it all comes together. Hopefully you've arrived here after watching my building science introduction videos 1 and 2. What we're going to do here is we're going to take a lot of that information and more, and we're going to put it into a very reputable energy model from the U.S. Department of Energy, one of which I use. What that basically does is it shows us, after we put a lot of information into this model, exactly what the home design will look like in reality. And what I mean by that is there are actual weather files that these softwares use as to simulate rain, snow, whatnot, wind, and especially here in Wichita, Kansas, and then outputs some kind of utility bill or different other bar charts that I'll show you here in a minute. We're going to get into looking at some different bar charts. But before I do that, just to let these models have been developed by the U.S. Department of Energy and a lot of other laboratories around the country. And so what I mean by develop is that the actual homes have been built. They've been instrumented with instruments that feed up into these software programs and make them accurate. But they're only as accurate as the person that's actually putting the information in and looking at the information that comes out. Not anybody can do this. It takes a skill set, a lot of experience. Okay, what I'm going to do is run through the input screens really quickly. I'm not going to spend a lot of time on it. If you want more information, if you're interested in buying one of my homes, I'll be glad to sit down and go over this in any detail level that you want to. What we're looking at here is I put this 1,525 square foot home here, a 3-bedroom, 2-bath, and I put some neighbors around it. As you can see, the orientation's defined. The solar panels will be on the back in this situation. And what we're going to do is we're going to run some simulations between the average home at 1,525 square foot that you would find here in Wichita versus the Paraflat. This is another input screen. As I said before, it's critical what you put into this thing to get the right output. So what we have here basically is we go through, we define a lot of the energy attributes of the two homes that we're going to compare, including the orientation, north, south, east, or west, how far apart the neighbors are, the walls, the insulation levels in the walls, the ceiling insulation levels, the foundation, whether it's carpet on the floor, the thermal mass I mentioned in my introductory videos, because they are heat sinks and moisture places to store things. In other words, that you could store moisture and heat. The window sizes, whether the windows are smart, what kind of shadings around these homes, the airflow. Again, that airflow, air leakage, I told you in the introductory videos that we leak down the house, we pressurize it, we blow it up, we fill it up like a balloon, and we watch how fast it leaks down, because that's important. We don't want to take those air conditioning and send it outside. So all kinds of other things here. And then this is where you get into your HVAC systems, that you can come up with different types of HVAC, your furnace and your air conditioner, in other words, and ventilation, exhaust fans, blah, blah, blah. So here, your water heater, lighting, what kind of lighting you have, whether they're LED lights or incandescent, and then your appliances, what kind of, even down, what we have here basically is, real quickly, is a lot of standard schedules. What I mean, how often do you plug in your computer? How often do you turn on the lights? How many, the occupancy rate? How many people are in the home on average? So a department called Building America has come up with these standards that we use. So anyway, just continuing on real quickly here. It even has PV, or solar panels would be another term for PV. Just to make that clear. I'll wrap up this input screens by showing you real quickly what this is really with the site screen. In other words, here we have weather files I could pull in a weather file either from Jabbar Airport, Mid-Continental, or McConnell. And so wherever the home is, I can get accurate weather files. And these weather files, by the way, what they have in them here is you got your sun information, wind speeds, temperatures, relative humidity, snow, and whatnot. That actually the kind of information that you get from your meteorologist on television is right here in this model. So that without that, there's no way that we could begin to understand what's going on here. To take it further, there's this model is not only a technical model, bringing in all those kind of technical information, but it's also a financial model that runs complex formulas. I'm going to try to make it real simple and go over real quickly. The economics here pretty much shows some kind of analysis period. Like let's say your loan's 30 years, the inflation rate that we see here, and some other factors on mortgage, your down payment that may have been put down, the interest rate, today's interest rate, income tax information, and then over here we have our friend Westar Energy and Kansas Gas putting in their what they're charging their fixed rate $14.50 per month for Westar, and they're right now at 11 cents a kilowatt hour. By the way, these companies are going up at 3 to 4% a year. What we have over here, PV or solar panels, actually that cost is coming down around 13% per year. So the solar panels eventually, and they do make sense here in Wichita. I have outputs that this model has generated. There's some parts of actually Kansas that generate more solar panel electricity than California. It just depends on where you're at, especially if you're blocked by mountains. We here in the plains have open access to the sun. So the solar panel thing does make sense here in Wichita. So after lots of times of setting up the models, I go get a cup of coffee, come back, and I have utility bill differences between the average home in Wichita here at, $21.92 per year. That's around $180 a month. That's pretty accurate if you go out online and look at the averages here out of Westar. This is this one here, because they do use a furnace, and so their gas and electric has got both gas and electric utility bills in it. The paraflats over here, you can see that it's an all-electric design. It's all blue with the electric and gas is in red. Anyway, so $13.27 a year, that equates out to about $110 a month. When we put the solar panels into the financial model and spread it out over 30 years, and it crunches out that, I have financial information I can sit down with you too. That's around $60 a month. So 180 minus 60, that's quite a savings, $120 a month that you could go do something else with, don't you think? I do. Okay, here's another bar chart showing the how much what size. This is how you actually size the furnace and the air conditioning systems. The red is the heating capacity, meaning how much you need to heat this house and how much you need to cool it. As you can see, the average home in Wichita is on what's called BTUs per hour. That's pretty much how we size up these HVAC systems. It's 165. Look at the paraflat. It's way down here. A lot of the paraflat, there's other loads here that the PV panels are taken care of, but there's no way you would need a roof, a humongous roof, to be able to take down and be able to supply enough electricity for this standard home over here. It's not even possible. Without huge amounts of money going into PV. It would not make sense here. Absolutely. This is why we do design the way we do, so that we can eventually go to 100% clean energy. These bar charts right here are really the heart and soul of why this whole industry is heading this way. As I said, the government's starting to mandate that our buildings are putting out too much pollution to our atmosphere for our future children and for us to live in. So if you can see here, what's called CO2 emissions over here in metric tons per year. The average home, and not just in Wichita, but across the nation, is putting out way too much. It's out there in 13.2. The way the paraflat is designed at 7.6. With the solar panel, and the more we pull out and we supply the loads, like I said, the water heater, the heater, the furnace, I should say, the AC and the electrical appliances, blah, blah, blah. The more we can pull out and supply PV, the solar panels, to take care of those electrical needs, the lower our CO2 emissions are. That's called clean energy. The utility companies are not liking the solar panel situation. They're using fossil fuels to pollute our atmosphere, and so eventually, this PV solar panel thing is going to be on most rooftops around the country, and the utility companies are going to have to rob Peter to pay Paul meaning that those still on that grid or tied to the grid are going to have to pay for the ones that are going over here to a cleaner energy source. And so what the problem is, though, the reason we still have to be tied to the grid is because in the wintertime, the solar panels just don't produce enough electricity. And the utility companies know that, so they're starting to pull back on, their credits, I should say, for supplying clean energy. And so they're not liking it, in other words. Finally, this is probably more for the professionals out there, industry professionals, but maybe I'll try to simplify this. You can get appreciation for prior to 2015. And as I said, the Paraflat's design above and beyond that. And this shows it right here. Prior to 2015, and what I have modeled here as a mainstream home for Wichita, Kansas is, it's called an energy rating index, meaning that prior to that, you might see around town some builders boasting about a low HERS score, home energy rating, and that's gone now as of 2015 because of the new requirements to blower door test or leak down the house. Now we have what's called an energy rating index, which, as you can see, has a lot more stringent requirements for it. So the average home in Wichita is failing miserably under this new index 2015. I don't even think a lot of the homes actually are meeting the 2012. I talked about it, IECC, International Energy Conservation Code. I don't even think a lot of the homes are meeting 2012. There's nothing being mandated here yet. There will be soon. Paramount Homes will be ahead of that. So that's why we make sense. Right now, our energy rating index, which is according to the minimum required by 2015, is that with our solar panels is at 16.7, which is extremely low. Hopefully that was educational and informative and demonstrated how the Parahome is the next generational smart home of the future. It is where new construction is heading. We don't like mechanical devices, like it said, that don't sustain or last and cause maintenance fees. In addition, we like clean energy sources like from solar panels. The solar panels industry is moving fast. Next year, we'll start seeing panels that match the roof cladding or are part of the roof, not attached to the roof, and battery packs that make the solar panel even make more sense. We can also put those solar panels on the ground on a pod if you don't like them on your roof. In the future, gas will make less sense and all the combustible hazards that go along with it, including indoor air qualities. Thanks for watching. You'll find more information on how to contact me and some additional informative links at the bottom of this video.